So, what if I told you there's a concept, an idea so powerful it could actually shatter the foundations of logic? An idea so dangerous that for centuries, some of the greatest minds in history just refused to even go near it.
It just sounds impossible, right? I mean, how can a single concept, a single number, literally break math? It's the very system built on unbreakable rules. And yet, for thousands of years, one concept did exactly that. It wasn't just a puzzle, it was seen as a genuine threat to reason itself. And that concept was infinity.
All right, so let's get into it. To really understand why this idea of something that never ends was so terrifying, we have to go back. I mean, way, way back.
See, back in ancient Greece, around the 5th century BCE, infinity wasn't some helpful tool you used to solve problems. No, infinity was the problem. It was like a weapon that twisted logic into knots whenever you tried to face it head on.
And the best example of this comes from a philosopher named Zeno. His famous paradoxes showed how a simple act like, say, walking across a room becomes logically impossible if you can divide space an infinite number of times. I mean, think about it. To get to the other side, you first have to go halfway. Okay, easy enough. But then you have to cross half of the remaining distance, and then half of that distance, and so on forever. You basically have to complete an infinite number of steps. And if you can never finish an infinite list of tasks, well, how do you ever get there? Suddenly, infinity makes reality itself seem like an illusion.
So, with logic itself seemingly on the ropes, the ancient world desperately needed a solution. They needed some kind of rule to put this monster of an idea back in its cage. And the person who stepped up to do it was none other than Aristotle. He saw the chaos that Zeno's paradoxes had unleashed, and he tried to contain it by drawing a really clear line in the sand. Aristotle's solution was actually pretty brilliant. He split the idea of infinity into two types. First, he said, you've got potential infinity. This is like a process that can just keep going forever, like counting numbers. 1, 2, 3, you can always add one more. That, he said, was totally fine. But then there was actual infinity, this idea of a finished, complete thing that already contains an infinite number of items all at once. That concept, he declared, was a logical absurdity. It was rejected, forbidden, kicked right out of formal mathematics. And get this. His rules stuck. For almost 2,000 years, mathematicians just avoided infinity. The idea was so powerful that it was basically relegated to philosophy and religion, but you did not bring it into your equations. But, you can't keep an idea that big locked away forever. And eventually, it came roaring back with the invention of a whole new kind of mathematics. And you can just feel the tension building over the centuries on this timeline. You have Aristotle's ban holding strong for ages. Then bam, the 1680s hit. Newton and Leibniz invent calculus, this incredible new tool, but its engine is secretly running on those forbidden infinite processes. And by the 1870s, it's a full-blown crisis. Math's most powerful tool is built on a concept that nobody can actually define or defend. And that was the crazy part. Calculus worked. It worked perfectly. It could predict the movement of the planets, for crying out loud. But for mathematicians, it was like they'd been given a magical car that ran without an engine. They were using it, but they were deeply, deeply uncomfortable because it was all built on a logical foundation made of sand. So this crisis was just begging for a hero, right? And this is where our main character enters the story, a man who decided to stop running and actually face the monster head on. So in the late 19th century, this mathematician, Georg Cantor, did something absolutely radical. He just ignored Aristotle's 2,000-year-old rule. He decided to take that forbidden actual infinity and treat it like a real thing, an object you could actually study and understand. He used this concept he called an infinite set. And really, it's a simple idea. It's just a collection of things that never ends. Like all the whole numbers, 1, 2, 3, and on and on and on. But by treating these sets as real objects, he discovered something that just blew everyone's mind. Cantor proved that some infinities are literally bigger than other infinities. He showed that the infinity of whole numbers, 1, 2, 3, is a different, smaller size than the infinity of all the decimal numbers you can find between 0 and 1. It was a revolutionary, completely counterintuitive idea. It meant there wasn't just one infinity, there were many. Well, the mathematical establishment was absolutely furious. His biggest rival, a really powerful guy named Leopold Kronecker,
saw Cantor's work as pure fantasy. He famously said, "God made the integers, all else is the work of man." He was basically accusing Cantor of committing mathematical heresy. And this constant, vicious opposition took a terrible toll on him. These relentless attacks on his life's work contributed to a series of severe mental breakdowns. Georg Cantor died in a mental institution, his revolutionary ideas still rejected by most of his peers.
But that, of course, is not where this story ends, because sometimes the ideas that are rejected the most fiercely are the ones that end up changing everything. You know, history has a funny way of being the final judge. And despite all the rejection Cantor faced while he was alive, his ideas about different sizes of infinity didn't just survive, they went on to become absolutely essential. I mean, just look at this list. Modern computer science, how we understand physics at a fundamental level, an entire branch of math called set theory, even cosmology, all of these are built directly on top of Cantor's work. Our modern world simply wouldn't exist as we know it without his courage. So here's the big takeaway. Infinity didn't just challenge mathematics, it broke it. And by breaking it, it forced mathematicians to rebuild everything on a new, more powerful, and ultimately a more honest foundation. It's really an incredible story about how a forbidden, dangerous idea can become an essential truth. Which, leaves us with one last question to think about. Infinity rebuilt math. It makes you wonder, what's the next idea that's going to come along and break it all over again?